Okay, question 15 here. We have a block of wood that can float in still water and it is partially submerged. When it's pushed down and you let go, it actually starts bobbing up and down. The frequency is given here. Okay, now since surface wave are then incident, so this first equation actually tells you what they call the natural frequency of oscillation. Okay, this is in other words, you press the wood down and let go, and it start bopping up and down on its own. So that frequency is called natural frequency of oscillation. Um, that the frequency depends only on the mass value that's and other factors, but there are no other force, no other periodic force disturbing it. Okay. Then the next paragraph: surface wave are incident on the block, so that resonance occurs in the up and down motion. So what happens is that when this you introduce wave, okay, introduce wave. What happens is when a wave come in, when a wave approaches, it actually the vibration of wave actually adds energies. The water wave actually has energy bobbing up and down. The wave as it passes by, it actually causes so the wood here will actually absorb the energy of vibration. The energy of vibration is the vertical direction. This is called transverse wave when you learn about it in the next chapter. So when a wave comes in, it actually causes, actually trying to give the floating wood some energy in the up and down direction. So so resonance can occur. Resonance means large amplitude oscillation. Resonance occurs means this wood is going to bob up and down with very large amplitude. It happens because the frequency of wave or the external frequency is more or less the same as the natural frequency. Okay, it's more or less the same as natural frequency of this piece of wood here. So when that happens, you have a large amplitude oscillation. So in part A, describe, explain what happens if the following changes. I mean, water waves of larger amplitude. Larger amplitude means you have more energy. So the water wave have larger amplitude means you have more energy. So when you have more energy, what do you expect? You expect the amplitude to become larger. Okay, okay, the amplitude become larger, more energy from the external force. So you expect a larger amplitude, larger amplitude of vibration. Okay, right. Then next part, the distance between the wave crest increase. If you remember wave theory, it is from your O levels, V equals to F lambda. So the wave speed, this is the wave speed. Wave speed. Wave speed is the same in the same water. The wave speed is the same. So this lambda uh, lambda is higher, increases means the frequency of wave becomes smaller. Okay. This one is actually when so initially they are in resonance. The two frequencies are the same. The frequency of the wave is equal to the natural frequency of the mesh. Now you decrease this thing. So when you decrease it, you move away from resonance. So in it, remember the resonance curve, something like that. You're somewhere here. Your wave frequency is same as your external frequency of the wave is exactly the same value as the natural frequency. Now you move away to a lower value. So your wave frequency now become a lower in value. You move down from to here. So you expect the amplitude to decrease. Okay? So the amplitude becomes smaller, okay, because the frequency of wave no longer is no longer equal to natural frequency. So you're moving away from the peak of the resonance curve. It doesn't resonate anymore. Okay, it doesn't absorb as much energy compared to the case earlier when it was having the same frequency as the natural frequency. Okay, the next thing is, but see, the block has absorbed water. If you look at the equation, this is the natural frequency of the block, 1 over 2 pi square root of 32 over m. This is the mass of the block. So the mass of the block, this is the natural frequency. So the natural frequency is dependent on the mass. So when the mass becomes bigger, so the natural frequency becomes smaller, okay, decreases. So initially your external force was force frequency is here. Your natural frequency is also here. Now your natural frequency moved to here. Your natural frequency moved to a lower value. So again, you move away from resonance. So the amplitude would therefore also decrease. So amplitude will decrease. Amplitude will decrease uh, because the natural frequency becomes smaller now. Okay, so natural frequency becomes smaller, decreases. So again, not equal to external frequency, not equal to frequency of wave. So again, you move away from resonance. Okay, so that's why your um, the amplitude decreases. Okay, so for part B and part C, the amplitude decreases. For part A, the amplitude increases because you're actually putting in more, you're giving the wave more energy, and the wave will transfer more energy to the mass.